언제였던 건지 기억나지 않아. 자꾸 내 머리가 너로 어지럽던 시작.
한두 번씩 떠오르던 생각 자꾸 늘어가서
조금 당황스러운 이 마음.
별일이 아닐 수 있다고.
사소한 마음이라
Okay guys, welcome back to your next lecture. So we're already in lecture 5, and in this lecture we'll be talking about network routing, which is the next big chapter. So we have already talked about network addressing, and you can tell that network addressing is a really big chapter because you learn a few rules, what kind of IP you can assign, things like that, how to calculate IP address. The next one, network routing, is also a big chapter, and over here you will learn the basic concepts about network routing, which means that what actually happens and what is working behind the scene when we send packets from a network to another network, which actually also means how the internet works, because the whole internet are just routers, and we need to configure all these routers to talk to each other so that we can use the internet. So that's the first part. And the second part of this lecture, we also showing you how we can configure this router. So we'll go hands-on. And for us to do that, we have our playthrough again for these lectures. It is called the avengers.zip, up on Weber already. Please download the Avenger file. We have 4 files in fact. If you open the zip file, there are 4 PKA files. You go through each of them, and all 4 of them, you have Avengers 1, 2, 3, and 4, and they are continuous. Okay, we will start with 1, and then 2, and then 3, and then 4. And with that, once you finish the whole Avenger, and you do endgame, finish the whole thing, then I think you are ready for routing configurations. Okay, so that is the whole idea of what we want to learn for lecture 5, and it is very important for you to try to follow, because this will help you to do your lab 3, which you will have next week on network routing. Okay. Okay, now before I start, I'll address some of the questions first. Whether we have our midterm. Actually, the teaching plans is already up on Weber during the first 3 weeks. Now it is already hidden because there are too many info on Weber. I don't want you to get confused, which is why I have already hide it. Now, for those who haven't got any of the teaching plan, then I will make it visible again for a short while. So please make sure you get everything that is up on Weber as I put it on. Otherwise, if I just leave everything there, it will be very messy. And if you don't get it immediately, like 1 or 2 weeks time, then you might not see the file anymore. So please always check Weber, get whatever is there. So let's get back to network routing for this lecture. So one simple sentence that when we talk about routing is that you see so far everything that we have learned is on LAN. So we have learned about addresses, how to connect devices, and all these things is in our own local area network. So we are not concerned about what happened when I want to talk to someone which is on the other side of another network. What we have learned so far is that we know if I want to talk to someone which is in the same network, I will send it to a switch. If I want to talk to someone which is on another LAN, I'll send it to a router. Now, in this lecture, we want to know specifically when we say send it to a router so that it can go to another network, what actually happened along the path on the internet, meaning that when the packet exits from your own router to the next router, what actually happens, and how the packet goes from one router to another, and then how we can configure this router so that when a router receives a packet, he knows what to do with that packet. So that is network routing. Okay, so before that, I'll play a video for you to explain the concept of network routing using an example that you are already familiar with, so that you get to know what is routing about. Then we'll start to talk about the first type of routing, which is called the static routing. Okay. Thank you for telling me. So what you mentioned earlier is that what is going on when we send a packet from one LAN to another LAN, and everything involves router. You can see router is doing forwarding, router is doing checking. So we want to go deep in this lecture and we want to find out what exactly is the router doing. And it's already on. Is it on right now? Is it working? Because I can see that it is already on. Okay, just so you know that there is like 10 seconds delay on a YouTube live. So when you tell me something, you can only look at my reaction 10 seconds later. So that's why, actually I see you, that's fine. Okay, I can feel you. Now, I'll just repeat this again. So what we want to know is exactly what happened inside a router. How does the router figure out how to send a packet from a source to destination? And to do so, we'll be using slides in this lecture because I think this will be helpful when you do your revision. So the slide is already out on Weber. I will show you the slides here. And we will start with the first slide. Okay, just let me bring this chat up here. Okay, now the first thing that we should know is the thing called a route. So on a computer network, hold on guys, let me restart the slides for a while. Okay, now over here in these slides, what you're seeing is we call a route. So route is just a path, or some people call this a path that connects one network to another network. And remember that along a path there can be many routers. It is not just one router to another router, which is why in the video you see the thing called the edge router. So the edge router are all the routers that is sitting in your LAN that connects your LAN to another LAN. That is edge router. Now after that, when the packet go from your LAN to another LAN into the internet, there are many other routers that is doing all the routing and forwarding, and those routers belongs to the ISP. It belongs to TM, it belongs to Maxis, and those routers are called the backbone router, or some people call this a core router, which means that they are responsible to forward all the packets across the internet from a source to a destination. So a path, you can think of a path or a route as what is the way or what is the direction that the packet should take for that packet to reach a certain destination. Okay, so if you go to the next slide here, we want to learn about the routing logic. So you have seen on the video, everything that happens so far happens in the router. Okay, and when a packet gets from your PC to that router, what does the router do? In fact, it does two things. Okay, it do one thing, but it can happen in both ways. So first one is he will check whether definitely he don't have to check whether this is for a host in the on LAN or other LAN. Definitely it's on another network. That's why he get this packet, and then he want to see whether this packet to reach the final destination, what is the exit interface that it should send the packet to. Now for example, I will visualize this using another diagram for you. So you have a router like this, and we know that on the router you have many interfaces. That's why you can build many network here. So let's say we call this FA01, FA00, E000, E010. So let's say if I have 4 interfaces on this router, and the packets arrive here from E010, and it is supposed to go to a destination. So when the packet is in the router will check this thing we call a routing table, and to find out whether he should send this packet from the interface here to here, or he should send this packet here, or he should send this packet here. So this is what the router is trying to do. And the decision is made by checking at the routing table. So this process of packet coming into a router and then it go out from that router is called a forwarding. We call this process as packet forwarding. Okay, so you know that in this case you can either get out from 0, 1 or 0, 0 or E0, 0, and that is based on routing table. We'll look at that later. Now, there's one more thing that can happen is that it doesn't exceed any of the interface, meaning that when this router he received a packet, when he's trying to figure out whether he should send it here or here or here, there is no answer. Means that the destination is missing inside the routing table. Now, if that happens, the router will discard the packet, means that it throw away, and then he will generate the ICMP error message, send it back to the original sender. So it will happen in this way. The packet come here, I doesn't know how to send this packet out. I will return that to the sender, but I don't return the original packet. Of course, I will return an ICMP error message. And that is why some of the time when you ping a host, you get destination host unreachable or request timeout. That's because the router don't know how to send, and he send an error back to you. So that's only the two things that can happen, and that is happening inside a router. So if you go back to your slides again, this explains the whole slide. So what the example that I give you earlier explained, I have already explained this using the visual earlier. So if you are interested, you can read more about the text here. Now go to the next slide here. What you are seeing here is we call this a routing table, and every router need to have one routing table. The routing table can be very big or can be very small, depending on how many routes that you configure on that routing table router. Now, if the routing table is very big, it will slow down the router because the router have to find so many different routes when it is trying to make a decision which interface I should forward this packet out. Okay, which is why if you want to have a big routing table, you need to buy a more expensive router that has more memory, better processor to support more different routes. Now in this case, what you're seeing here on the slides, you have three routers, router A, router B, and router C, and their routing tables are shown. If you can see the arrow here, those are the routing table for each of the routers. And over here, now what we want to learn in this slide is we want to learn how you get all this entry here. Okay, now we'll do this in two ways. This is the basic example. So over here, I will show you how you get all this value. You understand briefly about what you have inside a routing table. On the next slides, we will go deep into the routing table and then we explain each of the attribute inside the routing table. So what you really need to know here is how you get all this value. Now first thing, remember the job of a router is to send packet from a LAN to another LAN, which means that what they need to know is how to get to a particular destination network. So the first thing that you will find in the routing table is called the network address of the destination. So what you are seeing here, the first column of each routing table here. Okay, let me refresh the slide a bit. So you see on the slide here, the very first column is the network address. So over here, all this yellow color one is the network address. Means that, okay, now I take this as example, the first one here, 10.1.2.0 means for router A, if a packet want to go to 10.1.2.0, the destination is this IP, then the router A will do the following. We will talk about that later. So first thing, all the thing that you see right now in yellow color represents network address of the destinations that you're trying to go to. Okay, now the next thing is you will see here, I will use green color. What you see here in green color, which we call the next hop, is the interface that the router should forward this packet to in order to reach the destination. Okay, I'll repeat this again. Next hop, sometimes we call this a gateway, is the next router or the next interface that your current router should forward the packet to in order to reach a destination. So for example, if I'm from Kampar, I want to get to KL. So I can take a ETS from Kampar to KL Central, and then I take a Grab car from KL Central to my home in KL. So you see, I don't go directly from the train to my house because they don't build ETS directly from the train station to my house front door. I have to take a Grab car, so I have to transit in between. So that transit is actually the next hop. Okay, so now what you don't have to worry about how I get this IP. I'll show you in a short while. Now what you need to know is next hop is the next router that is responsible to forward your packet. Okay, now the last column here that you see, I will do this in orange color. The one that you see in orange color, these are the interface, IC interface. Now, so what we mean by IC interface is a packet that gets into the router earlier, you have to get out from one interface. So over here, all the thing that you see in orange color is the interface that the packet should get out from. So you come in, you have to go out. You cannot stay inside the router. Okay. So again, first column is all the destination network that we are trying to get to. Second column, next hop, is the next router that will help us to forward our packet along the path. The last one, interface, is representing the exit interface on the router that a packet will get out from. Okay, so coming back to this network routing table here, now we are focused on the first router, router A. So remember, every time we talk about routing table, it is in context of a router. You cannot have a routing table for 3 routers. Every router will have their own routing table, and this is also important. You have to be careful what routing table that you're looking at. So if I'm looking at this routing table, it is referring to router A. So this information here doesn't apply to router B. Okay, so you have to be careful about the right routing table that you are looking at. And now I will start in context of this table. Now I don't want to care about the other two, just the first one. First thing, look at the first column where you have all the network address. Why do I have 4? Why not 5? Why not 2? Why not 1? That is because on this network that you're seeing right now, this example, you have 4 networks. So over here, the first thing is you should know that the very first thing you want to find out when you are trying to build a routing table is you want to know how many networks that is currently you have it on the network topology or whatever that you're trying to build. That's the first thing. So over here, first thing I will do is I will use red color to draw out how many network I have. Remember, what do we mean by network? Every interface on a router will give you a network. Okay, so over here I have router A, and on router A I have 1 interface here, 2 interface here, which means that this one here is 1 network, this one here is another network. So over here I have 1 network, I have 2 network. Okay, now I move on to router B. On router B, again I have 2 interface, which means that again I will have this network here, but this network is actually the same as the one that you have on router A because they are all both connected together to a network. So the E0 on router A and E0 on router B, they are in the same network, so we still count them as 1 network. Okay, now whereas for E1 on router B, this is a new network because every interface on the router give you a network. So this one you have the 3rd network here. Now let's move on to the last router C here. Again, you have 2 interfaces, so all of these routers are the same. All of them are having 2 interfaces. But that doesn't mean you have 6 network. You only have 4 because some of the network are shared. They are in the same network. So on router C, this side here, E0 on router C, it is in the same network as E1 on router B. So we don't add another network, it's still 3. Now the last one here, this is actually a new network. Now on the E1 on router C, we have a new network, and this is our 4th network here. So overall, that is how I know that on this example I have 4 networks here. By looking at the interface or the port on the router that's currently connected, that will give us networks. Okay, so I hope you are clear about why we have 4 entries here. That's because we have 4 networks here. And if you look at this properly, all of the entry that you have is actually what I highlight in green color. So the first line here, 10.1.2.0, is actually this network. Now I will use purple color. I'll just erase this color first so that it is not confusing for you. So this one is the first line here. This is where you get this. Now the second line, 10.2.1.0, is actually this one here. And 10.3.1.0 is actually this one here. And then the last one, 10.4.1.0, is actually this one here. So that is how I know that in the routing table of router A, there should be 4 rows representing 4 routes to these 4 networks. Okay, so in fact, if you look at router B and router C, all the destination is the same because we are in the same topology. So overall, you only have 4 networks. So all the routers, doesn't matter how many you have, they will have the same destination network address, which is what you are seeing in the first column on all the routing tables. Okay. Now, if you're okay with this, let me check on the chat whether if you're okay, because this is quite an important concept. I'll wait for 10 seconds for the delay and then I will go to the concept of next hop. So you guys is okay about the network address? Yeah, if you're asking what is the network address that you should put in, that is the network address that you see on the network topology. So whatever address you see there, you just write them down in the place of the network address, a destination address column in the routing table. Okay, I'm not sure whether beautiful music is from a class. Anyway, I'll just answer. Routing process is like when you have a packet want to go from your LAN to another LAN which is far away, then it have to go through a series of router, and the router have to figure out this packet for it to go from source to destination, what's the best path for it to take so that it can arrive safely. So for example, for me to go from Kampar to KL, I can take a train and then I take Grab car, or I can take a Grab car to Ipoh, I take a flight to KLIA, and then I'm still in KL. So there are many ways for us to get from a place to another place. So the job of router is actually to figure out what is the best way for you to send this packet over to the destination. Okay. So if you're okay, then we'll go on to the next example here on next hop. So we are already in next hop here. Let me refresh the slide a bit. Okay, now what does the next hop mean? This is a very, very important concept in routing. And you need to know this clearly for you to configure the router later. So next hop means that the next router that is helping us to send your packet along the path of the route to the final destination. So looking at router A, again in context of router A is currently connected to 2 networks. Okay, now if you look at here, router A is connected to 10.3.1.0 and 10.1.2.0. Now, one thing you'll notice is these 2 networks is connected directly to router A. Means I take a cable from router A, I connect to router A, and then I connect to end devices. It could be switches or PC or anything. And this is called directly connected network. Okay, this is important. Directly connected network means the network that is directly connected to that router. Now in this example here, let's say I am talking about this network 10.2.1.0. In context of router A, we say that this network here, it is not directly connected to router A because it is actually quite far from router A. Okay, now the next example here, if I ask you, is 10.4.1.0 directly connected to router A? No, because it is even further than router A. So the concept of directly connected network means that the network is like what the name says, directly connected. Okay, so let's say we talk about 10.2.1.0. we says that this network is one hop away from router A. So if I talk about this network here, okay, 10.2.1.0 is currently one hop away from router A. So one hop means that for router A to go to that network, you need to go through one router. So every router along a path or a route, we call this as hop. Okay, so for router A to go to 10.2.1.0, you have to go through router B, which is one hop. So it's one hop away. Now another example here, 10.4.1.0. For router A to go to 10.4.1.0, it is actually two hops away because they have to go through one router here, second router here. So this is called two hops away. Okay, if you want me to write it down, it will be two hops away. Okay, so I'll give you another example here. Let's say in context of router B. Now we are talking about router B, not router A right now. So I'm router B. There are two directly connected networks here. 10.1.2.0 is directly connected to router B. 10.2.1.0 and 2.0. Okay, so these are directly connected to router B. Now 10.3.1.0, this one here, we say this is one hop away from router B because for router B to go to 10.3.1.0, it has to go through router A, so it's one hop. Now for 10.4.1.0, from router B to that network is also one hop because for me to go, I have to go through router C, which is one router in between. So that is one hop away. Okay, so that explains the concept of what is directly connected network and what is when you want to go from one LAN to another LAN, how many hop, how far away we are. So we count them in terms of one hop away or two hop away. Okay, so right now we'll stop here. On the Friday stream, we'll continue with what is the next hop address and so on, and also we'll learn how to configure this static route. Okay, so thank you for joining, and again about the quiz, I will tell you more details as I have the new quiz here, and I hope that you don't get stressed out, just enjoy and have fun. So until then, see you on the next stream. Peace out. So guys, if you have any questions, I'll be answering your questions on the chat. If you don't have, then that's it, you can go now. And yeah, remember this week we don't have lab, so you can relax a little bit. See you on the next week.
단 하루의 짧은 순간 그때였던 걸까 그때 느꼈을까 설명할 수 없는 마음이 그대와 있으면 그렇게 떠올라 그저 이 순간 지금 함께한 모든 날들이 내겐 아름다울 뿐 It's beautiful time 매번 소리나게 가슴이 뛰고 It's beautiful day 아름다운 하루 그림 같던 날 영화 같던 날 모든 게 잊혀지던 너와 beautiful day 조금씩